Can we start?
Yes, I think we should start. Hi, everyone.
Hello, everyone. I hope you're doing well. Before starting, I want to thank you all for joining us today to learn more about the most important part of all data analytics, machine learning, artificial intelligence, which is data. I am Abir Hammache. I will be presenting this topic today with my mate, Meyssa Zouambi. We are Women Tech Makers Algiers ambassadors. Please feel free to ask any questions by sending them on the live discussion. Let's start. The problem with biased data. All of us in tech are in privileged position. We are creating, implementing technology that users or customers, but also society as a whole. However, AI is a dual-use technology, and with the good comes the bad. AI is not neutral. It is a mirror that reflects back to us the bias that already exists in our society. The huge success of machine learning applications in the past decade in image recognition, recommendation systems, e-commerce, and online advertising has inspired its adoption in domains such as social justice, employment screening, smart interactive interfaces such as Google Assistant, Alexa, and the like. Along with the proliferation of these applications, there has been an alarming rise of in reports of gender, race, and other types of bias in these systems. According to a Harvard Business Review study in 2017, only 3% of companies are making decisions based on data that meets basic quality standards. A more recent article predicted that most companies' of the primary reasons is lack of enough clean training data. And now the question that we need to answer is, are our data biased or not? When we talk about AI, we have to talk in terms of probability and statistics. No AI can be 100% correct in its predictions. As a result, there will always be some amount of error. Error is the difference between an estimator's expected value and its true value. So when we are talking about bias in AI, we actually mean error. Since there will always be some amount of error, AI administrators must decide how to handle that error. One way of asking how they willing to accept based on the amount of error in the prediction. From this question usually comes the question of what it means to be fair. Fairness is usually defined as a decision made free of self-interest, prejudice, or favoritism. But fairness is in the eye of the beholder. What seems fair to me may seem extremely unfair to you. And now, Meyssa will present some problems due to biased data.
Thank you, Abir. Hi, everyone. Now I'm going to present some stories and examples just to show the misconception we used to have about one day machines will do better jobs than human. Machines don't have feelings, don't have thoughts, they don't have subjective opinions, they don't have biases. But actually, that's very wrong. Humans have successfully transmitted their biases through the tools we are creating because of this biased data. The first example I want to talk about is Compass. And it's a really important example, you'll see why. Compass is used by judges over 12 states in the US. Its job is to help figure out stuff like should we let someone out on bail? What type of supervision a prisoner should have? The length of the sentence, if someone predict if someone will recommit a crime. And this tool had been shown to be biased towards Black defendants. And the data we have is like the Black defendants are 2 times more likely to be misclassified as being high risk of committing a crime than white defendants. On the other hand, the white defendants are 2 times more likely to be misclassified as being low risk of recommitting or committing a subsequent crime. So these data show us that the tools we make are impacting people's lives. Another example, which is the most famous one, I guess, is Amazon's recruiting tool. Amazon, as being a big company, wanted to build a tool back in 2014 to help screening the resumes. It wanted to just like diminish the amount of pressure the recruiter had by screening every resume. So they built this tool using their data, and um, after a year, this tool, the developer realized that this tool was not rating candidates based on their technical qualification in a gender neutral way. They were being biased towards women and given more chances to male in being selected. And and why this happens actually is because of the male dominance in the tech industry. The data Amazon used was data had like 10 years history of resumes. Most of them were men because men had had more applications and tech jobs. So the AI thought that male dominance in tech industry was a good thing, and it penalized women and resumes that had the word women in it. These two examples show that having biased data is not just a question about quality. It's something really important that should be addressed, and we have to know when our data is being biased. And for that, there's an important concept called the five W's, and Abir will explain it briefly.
So how do we know if our data is biased? Well, for instance, it is
Abir, are you with
important
us?
to understand the impact. Uh, Do you hear me?
Yes.
So the question is, how do we know if our data is biased? When we are making data, it is important to understand the impact of the data. Some individuals disproportionately impacted. Are they not as likely to receive a fair or impartial assessment due to inaccuracies in the data or systemic bias in heuristical decision making? To determine that, you must look at data your system is using to make its recommendations. There are several ways you can look at your data to determine if it's biased. You can think about it in terms of the five W's: where, when, who, what. And for each of these questions, you have to ask why. For example, why are the days old rather than minutes or seconds old? And why did we select this group of users to include in our data sets? The first question is where is our data being sourced from? You must begin by understanding the quality of the data you are making your decision from. Is the sourced directly from your users, customers, or it's being collected from third party? If it's being filtered, who and why? Is the data categorized or labeled? If so, who is doing it? Is the team sufficiently diverse? Are the categories or labels accurate and complete? The second question is when. When are your data coming in? How fresh or recent is your data? Making decisions based on data that are days or even hours can have a serious negative impact on any prediction or recommendation. The third question, who? Who are you getting data from or about? You need to know if the data you are using in your models are representative of all of your customers or users. Are you using data from a subset of all of your users or from a certain type of users? Are you getting data from a lot more of one group than another one? If so, your distribution is going to be unbalanced. The last question you need to ask is what? What categories are being collected and used? There are three kinds of data categories or variables to be aware of and potentially remove them from your data because they can introduce bias or error. Special data categories, proxy variables, and data leakage. For special data categories, you may also hear this referred to as protected classes of data or prohibited categories. These are categories of data that you may not consider in certain decision making, such as hiring or housing eligibility. These include race, country of origin, gender, age, or political affiliation. If any of these categories of data are used to train your model, you may be making a biased decision. The second type is proxy variables. A proxy variable is a variable that is not directly relevant by itself, but serves in place of another variable. If you, even if you are not using a special data category in your predictions, you might be using other variables that are proxy for it. For example, because of heretical practice readily in the US, zip code plus income are equivalent to race. That means even if you are not making predictions using the explicit race variable, if you are using zip code and income, the predictions will be influenced by race. The last type is data leakage, also known as hindsight bias. Data leakage results from using variables in your prediction model that are known only after the act of interest. And now, Mesa will talk to you about the different types of biased data.
Yes, thank you, Abir. Now we're going to see the different types of bias data. The first one is selection bias. Um, now, selection bias is when we train our algorithms, when we feed our machine data that is not relevant to the whole population. We just choose a subset that is not quite qualitative and doesn't represent the data we need in our algorithm. Let's say, for example, we want to develop a tool and we send a survey to our colleagues asking them if they think it will be a good idea or if they will use this tool. Let's say most of the response will be positive, like 90%, and you think you found the greatest idea ever, you develop your tool and you deploy it. But the response of the whole community, all the society isn't quite the same as your colleagues. So here we have a problem of selection. When we choose to select to sample data, we need to have different categories, and we need to use data that will be the same as the environment that the program will be used in. The most typical reason, let's say, of the selection bias is just collecting data that is easily accessible. For example, your colleagues. It will be harder to sample the Algerian population, for example, to collect this data. So that's one of the reasons of selection bias. Another example of another type of biases that we have as the observer bias. And human, let's say, we tend to see and we tend to hear what we expect to see and what we expect to hear. So observers, when they conduct an experiment, they come with prejudices, they come with an idea, a feeling, a subjective thought about how the outcome of that experiment would be. And this may lead to collecting biased data. If they don't have a clear protocol on how to interpret the results they have of their experiment, they tend to interpret it the way they think. An example of this is the BERT experiment. Back in the 1960s, I guess, this psychologist conducted an experiment. Well, he thought that the IQ of children who had parents who in the working class were less intelligent than the children of people who had higher status. So he conducted the experiment and collected data mm, that confirmed his thoughts, and because of that, England made a sub-educational system for people in the middle class and for people with higher status. And later on, it was discovered that the whole experiment was biased and the data it has was biased. So another example of another type of biases that we have is um, the response bias. That's actually really important because it's something we see every day. When we have, for example, our social media, we see most of the people have the same opinion. But did you know that um, the most data that comes from Most data come from few sources. We have Facebook, for example. 7% of the users produces 50% of the posts. So it's not actually significant if you see our whole Facebook feed with the same ideas. It doesn't really mean that every user have the same thoughts. So data we use cannot be inferred uh, and say that it is significant to every user we have. Another type of biases, um, bias data is the omitted variable. The omitted variable bias. This occurs when we forget variables that can have a high correlation with our target, a high correlation of the results we want to obtain. So certain events or action cannot be recorded due to privacy or other aspects because it's inaccessible or something, but these variables can have a big influence on the outcome, and omitting them will give us biased data. The final type of bias I want to talk about is societal bias. Remember the selection thing when we just choose a part of our population and we give them surveys, for example. But what if this time we get the whole community? We have the perfect sample, everything is fine, but our society in itself is biased. I mean, even the data we gather from it, even if it shows exactly what everyone thinks, but what everyone thinks or what most people think is wrong. So this is societal bias. And because AI system learn to make decisions by looking at historical data, they often perpetuate existing biases. So we have to prevent that. So we have to get rid of these biases, even if they are embedded in our society. Now Abir is going to show you, is going to talk about how to identify and correct these biases from our data.
Thank you, Meyssa. So to identify and correct our biased data, we need to add bias testing in our process. There are two famous tools that can do the job: fair machine learning and Lime. There are toolboxes for diagnosing data, diagnosing bias in predictive modeling, and they audit them and determine the significance of the inputs. At the end, I should say that hope is the belief that our tomorrows can be better than our todays. Hope is not magic, hope is work. We can't hope that we are implementing unbiased technology. We must work to identify and remove bias. If we are not a data scientist, it can be intimidating to understand many of the statistical concepts related to AI and bias, like collinearity and data leakage. But we have introduced some concepts that should make all of this a little less daunting. Thank you for attending this session. I hope you could learn something about dirty data and how to clean it. Together we can stay safe. Thank you.
Thank you, everyone. I hope you enjoyed this session.